Energy Symposium sponsored by the Energy Institute. I'm Carrie Keene, research scientist and assistant director of the Energy Institute. Before I introduce today's speaker, let me just highlight on our website the speaker for next week, who is Tom Smitty Smith. He is director of Texas Electric Transportation Resources Alliance. Some of you in Texas might know him better as the former director of the Texas chapter or Office of Public Citizen. Smitty has been around energy and environmental policy in Texas for several decades, and he's going to talk to us about electric vehicles, how fast is the evolution coming, and what should Texas do about it. And he's going to talk about the new organization that he's a part of. Today, we have Ellen Stechel from Arizona State University. And I will bring up her bio. So Ellen is the director, or co-director of ASU Lightworks. He's going to explain to us what exactly that is. She's professor of practice at the School of Molecular Scientists, a senior sustainability scientist, the Julia Ann Wrigley Global Institute of Sustainability, for them, and a fellow of Institute for the Future of Innovation and Society at Arizona State. Her research focuses on materials and systems design for high temperature technologies for producing sustainable liquid hydrocarbons from carbon dioxide, hydrogen from advanced water splitting, clean water, renewable ammonia, and thermochemical energy storage. She's also focused on policy-related inquiries with a focus on the necessary ingredients for a purposeful energy transition that is neutral and negative, and net carbon, affordable, reliable, resilient, just, all of the things we want to have. And that's why we have her today to talk about how her and her colleagues at Arizona State think about these questions. Her formal education is in physics degrees, but she has to have a lot of hats to try to bring people together, and that's the purpose of us having this discussion today. So I'm going to stop sharing my screen now and hand it over to Ellen for some introductory remarks. She and I will attempt to have a bit of a conversation as she goes through the material that she will be discussing. And I'll remind the audience to please go ahead and submit questions through the Q&A feature on the Zoom Q&A feature during this webinar, and we'll look to ask these questions perhaps as we go along, but certainly at the end, the last 15 minutes of the webinar. So now I will stop talking and hand it over to Ellen.
Thank you, Carrie. Thank you very much for the kind introduction and for inviting me to this conversation. While I do have some slides, is not going to be your normal, just typical technical presentation. I teed up some slides for from the conversation. Carrie and I have been having this conversation. The goal here today is really to have a conversation and not for me to just talk through these slides, but I wanted to tee up a few points, and in the heat of everything, I'd probably forget everything I wanted to say, so I put a few with some points on the slides. And I invited Carrie to please interrupt me with, so it does become conversational as he sees appropriate. And also if there's questions from the audience. And then I presume we're going to have time at the end for questions. But I did want to introduce Arizona State University. And not sure, one thing didn't say, I think in my bio, is I've worked in a lot of different places and a lot of different sectors, including in industry and a national laboratory and a government agency. And I will be working with a nonprofit foundation pretty soon. And I never imagined myself in university. But then I met my colleagues at Arizona State University roughly a decade ago, a little more than a decade ago. And I was really quite amazed with the vision at Arizona State and with the charter. And actually you can sort of see the charter in my background here. I'm not literally in Tempe, but the charter really focuses what a lot of us at ASU keep in mind. And that is that ASU is a comprehensive public research university. We are the largest university in the country. But very importantly, we like to measure ourselves by not whom we exclude, but by whom we include. And this is really important to the energy transition and to the complex challenges globally. and also, very importantly, how they succeed. We're also focused on advancing research and discovery of public value, and that's all we're talking about here as well, and assuming fundamental responsibility for the economic, social, cultural, and overall health of the communities that we serve. So some key words that keep focusing on mind is transform society, use-inspired research, engage globally. I think it's so unfortunate that with COVID right now, the only way we engage globally is over Zoom. I don't think it's sufficient, but it's what we have. And affordable education and lifelong learning. So breaking news, it just hit the press right now is ASU launches the Julianne Wrigley Global Futures Laboratory to transform the world for a better future. This is brand new. And the way our president was quoted in the newspaper was medical school for the earth. We don't have a medical school at ASU. New ASU lab to focus sustainable solutions for the future. And Lightworks, which is the initiative that I co-direct and predates my coming to ASU, which was in 2012. ASU Lightworks is a campus-wide broad initiative. It pulls together under one strategic framework, light-inspired research across the entire university. And it doesn't care what school people come from or what discipline they come from. And that's part of the title, how many hats. It really takes looking at these problems from every vantage point you can imagine, whether that's business or law or policy, political science, social science, humanities, and then the sciences and the engineering. And notice I put the others the reverse order, even though I'm a scientist and an engineer. So we envision a resilient and equitable future supported by innovations in technology, policy, law, governance, and markets. We pursue breakthroughs to achieve energy security, secure energy justice, and inspire future generations. We do focus on the energy transition. How are we going to get from here to there? And we'll come back to that. And we love to collaborate. And that's why I was so happy to meet Kerry King, for example, and so many others that we collaborate with. And I met him through some of our social scientists, actually, and not my engineering friends. But importantly, we collaborate with like-spirited people and organizations that share a common vision. We do focus on solar energy, that's the light inspired, because it's highly scalable, it's democratic. And what I mean by that is it's distributed much more equitably than any other natural resources, especially compared to oil, natural gas, and some critical elements. So just a little bit about me and what shapes my worldview. As a scientist, I lean towards what's possible, that's the science, and what's practical and plausible, that's the engineering. I'm a little less optimistic about policy and governance, ensuring what should be, but I can be hopeful and will continue to be hopeful. I do find there's a tendency for magical thinking in many of the narratives, and we like to talk about these competing narratives, but I do try to be realistic, and I look, obsessively at the world by the numbers. I do lean optimistic end of realism, but I try to stay realistic. As an R&D manager, I lean towards assembling multidisciplinary teams. I very much value diversity, including diversity of thought. I'm always questioning, are we solving the right problems? And a key one I always say to a lot of my colleagues is, are we solving problems and not solving solutions? Because we too quickly sometimes say, here's the solution, and then we lose sight of the problem, and then we go about solving the solution and miss alternative ways at looking at how to solve the problem. And always trying to use systems thinking, because one thing I always like to say is optimizing at a subsystem level necessarily suboptimizes at the system level. So just a taste, because I'm not going to be talking about research like in a normal technical symposium, But here's some of the research efforts in my group. This is not all of Lightworks. That would take a whole symposium all on its own. But I do focus, as Carrie said, on deep decarbonization with a special focus on the last 20%. That's the stuff that keeps people awake at night, beyond electrifying everything, beyond PV, wind, and lithium-ion batteries. We do focus a lot on hydrogen, production, storage, distribution, and end use. We do believe there's an important role to play in many of the hard to decarbonize applications. There are many challenges, but many opportunities. We also work on energy storage, especially long duration, including weekly and seasonal. And just for context, short duration is usually less than 4 hours. And that's going to be needed in any future scenarios that we can imagine. We do work on sustainable fuels and products, and that includes ammonia, carbon-free ammonia, CO2 utilization or CO2 recycling, synthetic hydrocarbons, and a lot of our work is in high temperature processing, including for those applications. We also work on bridging technologies such as capture-ready CO2 from utilizing natural gas. We used to say and look at natural gas as a bridge, but it was kind of looking like a bridge to nowhere. It is much more looking like a bridge to somewhere. Generally, we work on on the whole, from soup to nuts, if you will, on fundamental theory, on thermodynamics, especially at high temperatures. And high temperatures not evil if it's sustainable temperatures that we get from solar energy, material science, new reactor designs, systems, cost modeling or techno-economics, and market drivers. So I'd just like to also highlight that while we do look, I've been trying to emphasize systems, but we do look at things primarily through an energy lens. And we don't think that loses sight of the systems, because in general, affordable and clean energy supports almost any of the goals that you can imagine. And rather than, I do like to flash up the UN Sustainable Development Goals, and it's worth keeping those in mind. But the way I kind of like to keep in my mind as we're looking at, are we solving the right problems and what problems do we need to solve, is really imagining. This is the optimism in me, because I really do believe this world is possible. So imagine a prosperous world, that world with 11 billion people, and it could be more, and they're thriving. We have reliable, affordable, resilient, accessible energy and water for everyone. No net greenhouse gas emissions, no waterborne diseases or air pollution, no starvation, no poverty, social justice, which means really equitable distribution of wealth and opportunity for everyone, and no longer unsustainably depleting natural resources or destroying natural ecosystems. I might have missed a couple of things, but I think that mostly covers the world we would like to see. And so when we think about that world, and call me idealistic, call me, I don't think this is magical thinking. I think it's, we have a lot of work to do to get there. So our key question is, how do we get there? And can we be purposeful? Where and when do we need to make deliberate interventions? And I will say we won't get there through photosynthesis alone. A lot of my bio friends don't like me saying that, but I believe that's true. We won't get there with only renewable electricity and lithium-ion batteries. I'm not saying these things aren't important. I'm just saying they're very necessary, just not sufficient. We will need technology, societal, and policy innovations to create this world. And the scale, while almost unimaginable, as I said, I watch the numbers very carefully, but not impossible. So I want to say something about the energy transition. And I do think, the climate wars, the way we think about this is the climate wars are won. We are in an unmistakable energy transition fueled by decreasing costs of renewables and a lot of ambitious targets from many entities. But still, given that, we're very little that we can predict about that world and what it's going to really look like in 2050. But I think there are a few things that are inevitable, or at least should happen, and that is increasing roles for, certainly we're going to be carbon constrained. We're going to have a lot of stochastic primary energy resources. There is going to be a role for hydrogen. There is going to be a role for direct air capture. It's going to be important to getting to net neutral and net negative and capping costs. Probably a role for synthetic hydrocarbon fuels, long and short duration storage, which I kind of mentioned, continued need for fertilizer, concrete, steel, mining, durable manufacturing, but we're going to have to do it more sustainably, more distributed, more modular, more flexible, but economies of scale will still provide necessary resource efficiencies. So I'm not in favor of relocalizing everything. And we're going to use more energy, not less, and I think that's okay. I think I had mentioned a slide ago, that we need interventions. And one of the things I hear a lot, and it drives me a little bit crazy, is do we need population control? And it really is often the elephant in the room. And a lot of people will say, well, we can't get there without controlling population. But when we think about interventions that have really huge impact, it's a little bit of an aside, but I can't not say it, is educating women gives the biggest bang for the buck anywhere. It's the greatest thing since sliced bread, as they say. And it creates a positive feedback. The workforce diversifies, you get better decisions, you get more innovation. As I say, I really value diversity. More children survive, less children are born, population will stabilize all on its own. If we can find other big levers like this, then we can make very big leaps with not too much effort. So this plot shows the number of babies born per woman as over time, and also with income. So raising incomes, the best thing we can do is actually lift people out of poverty. So this, I borrowed this. So Carrie shared with me an advanced copy of his book, which I'm still reading. I wish I had more time to, just read it. I have to do other things, but wanted to tee up some of this conversation because I did say I was an optimist, but I always say I'm a realistic optimist. So where I sit, and I think Carrie and we'll have more conversation about this. I do sit above the line, more towards techno-optimism, but not about, I don't look at it as infinite substitutability, just trust that, something will always come along. I see solutions, I see options, and that's what gives me my techno-optimism. In terms of finite Earth, clearly it's a finite Earth, but it's bigger than we think. So I think there's a lot of realism while staying within finite. And the same, it's not a choice, fossil or renewables. I do think we will have to be fossil free, but we're gonna have to find a way to make the transition smoothly and a little quickly. Part of my optimism is, I could spend a whole seminar on the numbers. Most everything in the world is getting better. Few things are getting worse, except for the way we're destroying our ecosystems. I think we can correct that. We do need to correct that. But lifespan increases with income, as we saw. The number of babies born decreases with income. Carbon dioxide, unfortunately, has been increasing with income. We have to solve that. What there isn't a limitation on is innovation. I don't believe infinite growth in terms of consume more and more and more is gonna, is sustainable, but I see no fundamental limitations on improving quality of life. And it has happened. If you see the sort of the time evolution of this plot, which is, the bubbles are population size and the colors are regions, we have been increasingly improving over time and lifting people out of poverty. There is still poverty and we're not done, but the trend line is very good, except for maybe sub-Saharan Africa. That's still worrisome. So when I look at finite Earth, it's finite. And I ask the question, what can we do with only 1% of land? Humans are using the majority of the Earth's surface, and this is bad, but it's not for the built environment. And it's not going to be for paving solar panels. So 1% of global ice-free land at just 10% efficiency, solar to end use, is 26 terawatts, 1% of global ice-free land, and not 100% efficiency, 10% efficiency. Primary energy that we use today is 18 terawatts. At end use, what we use is 7 terawatts. So 1% of energy can supply quite a bit. It's sufficiently scalable for all our primary needs, but all those primary needs does need to include food. And that's what we're using a lot of the Earth surface for. So what can we do also only with 1% of land? 1% of global ice-free land at a population density of Paris. And I don't know about you, I lived in Paris. I loved living in Paris. 29 billion people could live at that density on 1% of land. I'm not saying that's what we should do. 1% of global ice-free land. If we could make food at a 5% efficiency, solar, this is why I say not with photosynthesis alone, that could feed 108 billion people at 2,500 calories per day. Most durable goods and chemical processes can use only earth-abundant and non-toxic elements. We do have to change some of these processes. A cyclic economy can reach steady state with mobilized materials as the resource. We don't have to mine forever and keep extracting. No waste, only wasted resources is what I like to say, but with innovation, we can have enough feedstocks and enough energy resources. We do need the economy to provide incentives or disincentives and price signals. And I think there's still a few issues with the way we view the economy. Oops, that was not supposed to do that. We are in the middle of an energy transition, 2 previous energy transitions. But when we look at it as a percent, it looks like we phased out traditional biomass, we phased out coal. We didn't phase out anything. We look at it on the right, we only added new resources. The transition to renewables and fossil-free is truly unprecedented. So things are changing fast. Utilities are grappling with 100% goals. We're trying to help them figure out how. These were not supposed to be animated. Coal is not economically competitive. Policy for clean energy in many states. Renewables with storage are becoming increasingly viable and lowest cost. And for the foreseeable future, natural gas pricing will remain competitive. I don't believe in predicting the future, only creating options, and I am going to stop talking.
Right, thanks. No, you're going to keep talking, but
no, I mean, you didn't interrupt me. You were supposed to just let me keep going.
Right. Excellent. So a good quick rundown of what you're thinking and things going on at ASU. So let me think about slide 5 and thinking about multidisciplinary groups thinking different things. Use the terms on there was solar energy is democratic. Now you could sit here and define what one person might take solar energy, tell me what you think, and they might come up with solar insulation. They might say a solar photovoltaic panel. Who knows? That's a difference there. And then democratic. People will come up with different. I don't vote for the sun, right? The sun's out there. We're not voting in a democratic sense for the sun. So, it sounds like a good statement, but it also sounds like one that can get twisted. So, how do you find people? Is that statement something that your group agrees on, or do people use the phrase with different levels of apprehension? It's a broad statement, but I think we generally know what you mean, but it can go a lot of ways.
Okay, I did try to qualify it
Yeah, you did.
for just that reason. I mean, right now, a lot of the global problems, and the geopolitical and a lot of the wars is because our energy resources, our fossil resources are not evenly distributed. And so what I mean by the sun is democratic. While there's more sun in some places like Australia and Africa, in South America, in the southwest of the US, overall, the sun shines pretty much everywhere. Even, when I was in Alaska and talking with the energy authority up in Alaska, they said PV 6 months of the year is a great resource because they have long days. PV, in Germany, where the sun hardly ever shines. The sun pretty much shines everywhere. So that's what I mean by democratic. It's much more equitably distributed across the world. And
Right.
so so no reason to have wars over it.
So yeah, so how would we think about the equitability of obtaining the piece of technology or capital of, say, a solar panel in places that may or may not have democratic governments and may or not have a lot of money or for the incomes that you already mentioned? How much does talking about it democratic, I guess, take focus away from that versus, if they borrow money, like if you're in Africa and there's some person in the Western world who is going to loan you money to pay back their return on investment on a solar panel, is this a democratic proposition? Or so the Western world would be saying, here, have some solar panels, or should we loan them money for solar panels?
Well, a little bit. So the way I kind of look at it, and we have done some work in Africa, what's really important is that we don't just build solar panels for them or other solar resources, that we build in country capacity, so that there's also economic development that goes along with, or that we're creating, capacity. And I love, using education and training. And it isn't just, foreign powers, whether it's China or the US or anyone else, come in and just take advantage of them. So it's democratic if we build capacity and help them lift out of poverty at the same time.
Yeah, so complicated, helping other countries obtain capacity, which may include them having a more democratic form of government.
Well, yeah, that's a little more complicated. Yes,
yeah,
that's a little more complicated.
Right. So thanks for that. So another one on one of your slides, I love your statement here, that optimizing at the subsystem necessarily sub-optimizes at the system level. So I'll give my, I guess, favorite example, and then I'll ask for one from you. People talk about the idea of, energy rebound or backfire, often known as the Gevins Paradox, right? If you minimize efficiency at the device level, computer or refrigerator, whatever it is, this is not the same as minimizing energy at the overall economy-wide level. So we have consumed more energy at the economy-wide level globally, and we have more efficient devices at the subsystem level. It's maybe different than optimizing, but people expect often the opposite to happen, yet the data essentially do not support that. So more efficiency at the device is more consumption at the whole. At least that's my take on it. So you agree or disagree, or do you have another example about the subsystem and system level optimization and how we should think about it?
Well, from a technical standpoint, from engineering, when we're designing a system, time and time again, we see by relaxing, if we really optimize the subsystem and then try to put it into a bigger system, that we have to re-optimize. And that can get, kind of technical. So from just engineering a system, whether it's, a solar system like we're working on making renewable ammonia, each of those subsystems we're working on long duration storage. Over and over again, we see that we have to re-optimize all the heat flows at the system. But to yours, because that's also my favorite example, we called it the Rebound Effect, and I loved reading about it in your book. I didn't know it was called the Gevins Paradox, but the Rebound Effect, and is part of why I also, for multiple reasons, say we're not going to use less energy. Because yes, every time we get more efficient, and I worked in the auto company. So what happened when we made the car more efficient? People thought we weren't making it more efficient because we weren't getting better fuel economy. We put it into more power, or we put it into bigger cars. We use that dividend, if you will, in other ways. So efficiency almost never leads to using less energy, but it does lead to getting more for the same amount.
Right.
And in the sense of, climbing the increasing quality of life what we should be measuring is not how much energy is using, but are we using our resources responsibly, and are we improving people's lives?
Right. So in some sense, yeah, if you have technology A, B, and C, and you tune them to just work by themselves, you design them in one way. But if you have to make them all work together, say in the electric grid, then they have to be tuned in a different way. They have to be designed in a different way. And that's not always intuitive, but yeah,
Not all,
agree.
and you have to look at the whole system, because like coming to an example of localization, like it sounds very appealing to think about everybody making their food and all their energy in their yard. You save on a lot of transportation costs, you save on some of the distribution costs, but now let's look at the whole system. Did we really save?
Right, right. Yeah, so I can hold for utility scale power plants, or even, yeah, food, other things. So excellent. So we are getting a couple questions in, so I'll do one more comment on myself and then maybe go to one here in the Q&A. They're discussing of the birth rates and the, let's say, the education levels, or we could maybe say the civil rights of women and across the world as drivers for lower population, and then lower birth rates. And lower birth rates tend to come with increasing wealth, which can be a factor because of the women's rights. So with more income has come more consumption and lower birth rates. But we look at the data, right? We're definitely consuming more as a global body of materials and energy. So, so I sort of think in my head, a right question, is increasing income the answer, right? You have fewer people, but each person's consuming more. And if we're worried about climate change, then we're worried about the total in some sense, without regard, or emissions and concentrations in the atmosphere, without regard to the wealth of people necessarily. So I don't know, what kind of conversations have you had, or how do you think about this trick between increasing wealth, which essentially means not depending on the land for your income and farming and forests and these kinds of things. And so we become big consumers of fossil energy to date. And yeah, high consuming, but low birth rates is still more total consumption, at least so far.
So far. And I did have a little graph in there that, yes, just like the increasing lifespan, increasing CO2 looked, you could just about overlay that plot. So yes, with these, we have been increasing consumption, and we have been increasing CO2. So unquestionably, we've got to get to carbon neutral and sustainable practices. We've got to get to where it's a cyclic economy, not just always relying on extracting new resources out of the ground. They say, I think there's enough energy, in the sun. I tried to show that with the, just what 1% can give of land can give us. But we have to do all of these things sustainably. Do we have to, consumption, because we've been encouraging people buy more, buy more. At some point, that's why I try to emphasize increasing quality of life, because one more something is not necessarily increasing our quality of life. Doubling our income at the low end has a much bigger impact than that same incremental. Every doubling, we do get generally a higher quality of life. I think we need to focus on that quality of life and doing it more sustainably. I don't think it's contradictory, but we have to do it.
Right. Does that include, I guess, reducing the material physical consumption of people who already are sort of beyond this diminishing returns of quality of life? That would be most of us with a middle to high income in the Western world.
Well, not really in the Western world, in the U.S.
Well, U.S. for sure. Stay with the U.S. Okay.
Our consumption is double Europe, and they have a very nice lifestyle. So, yeah. I think I don't like to say we have to consume less automatically. I think we need to not be as wasteful. I think we need to think about what does improve quality of life and be more responsible but I don't think we have to go backwards in our quality of life.
Right. Well, we'll
Standard of
perhaps have a
living.
lot more data to think about this after the sort of the changes in how we operate due to the pandemic. I'm having a good quality of life speaking with you right now. So this is better than not doing it for me, for sure.
Well, yeah, I still rather, I mean, I used to travel every week. I'm not crazy about it.
Right. So I'll go to one question here that is related to what you have recently said. It's sort of related to the land. You're saying you only need, say, 1% of ice-free land to take advantage of enough solar energy. That's not solar power, of course, or instantaneous. And so you need that's where the technological optimism comes in. We've got to develop the storage technologies. Otherwise, you would otherwise take so much land that it's essentially not socially or environmentally tolerable. So I'm agreeing with you on that. That's where some techno optimism and the sort of engineering and science really play in. And so that's a counter in terms of the energy narratives, right? A person on the fossil energy narrative end wanting to take a pot shot at the renewable energy end would simply point both of those facts out. Well, you're going to need all these storage technologies, or you're going to take too much land, and then you're not recycling them. And then where are you now? And that's not better than fossil fuel. So, I mean, one of the questions here is about recycling, and you mentioned the circular economy. So I don't know, what can you say about what you know about the research going on, or your views on whether we can achieve a circular economy? And if given the nature of your work at ASU, whether there are economists, let's just say, think differently than the engineers thinking about the problem, and whether there's disagreements on how to think about it.
So I think without question, if we're going to be sustainable, we have to get to a circular economy. And that's what gets really, I think there's enough resources, but not if we don't recycle them. And recycling takes energy, and that's part of why we're gonna use more energy, not less energy. But there is enough energy. We do have to get to where we're recycling, and we're doing a terrible job right now of recycling. Some of the biggest problems with recycling are really the sorting, and and everything mixes all together. One thing I was pretty impressed with is just a little story of what can happen. It's like, again, I worked for Ford Motor Company, and one of the things Ford did is with Alcoa, so they made the all aluminum F-150. F-150, a very popular truck, and all aluminum, lightweight, very economical, fuel economy. And they cited the two plants next to each other. And so the virgin aluminum, they didn't have to use as much aluminum so aluminum is very recyclable to a point, but when they had any scrap from the making of the vehicle, they sent it right back to Alcoa. So it didn't mix into the whole stream. So a lot of the problems with recycling is everything gets mushed together and mixed together, and that becomes a very difficult sorting problem, and it's just cheaper to landfill it all. And with a lot of the technology that we have now with artificial intelligence and barcoding, and being able to trace and from beginning to end. And I did sit on a panel on the EPA. It's more than, it's almost 2 decades ago where they started to try to solve this problem. We haven't solved it yet. It's clearly solvable, but the incentives aren't lined up yet.
Yeah. You mentioned, you said barcoding, and when I look at my pieces of plastic that I get in my to-go containers due to COVID and more eating out, perhaps, there's no barcode. There's a little symbol that's some sort of rough approximation of the type of material it is, but is barcoding, I've actually even not looked into this. Is this something that people are looking at? If you impress a barcode into a piece of plastic that a machine could read, find the place to read, and then know more specifically what the material is and enhance the sorting?
I know people are researching it, but I don't know where it's going, or has it gone anywhere. I'm just, sort of saying there are, what I like about, innovation, when you understand a problem and you have the right incentives lined up, we're very good at solving.
Oh, right. Yeah, it's in the incentive. So there's a question here about, I guess, Africa. You talked about it before. Is there anything more you could say about work that you know of at ASU or otherwise related to Africa and low carbon transition, or well, getting energy to begin with and having it low carbon perhaps?
So a lot of my colleagues do work in Africa, and I was involved with Energy Africa and a couple of companies. It's hard. It's hard to work in Africa. There's no question about it. But I think it's very important. And I think the most important thing, you mentioned it, is, the lack of democracy, corruption, the changeover in every time you think you have things going, something gets in the way and stuff. But I think it's a really important part of the whole sustainability question is, on those plots, if you look at almost any metric, the place that we haven't made enough progress yet in pulling people out of poverty and electrifying, it's in sub-Saharan Africa. And we have an important place to keep our attention on. Not easy problem.
No. So there's another question here. It's essentially about, let's just say, energy storage of one form or another, pretty much, I guess, for the electric grid, we might say, and just thinking about lithium ion or whatever batteries for dealing with daily fluctuations and taking the role of natural gas peaking plants. How do you think about there? How far do you think we need to go on electricity storage, maybe just electrochemical, and how far do you think that can go? You say it can't go all the way. How far do you think it can go in terms of storing the energy from the grid or otherwise that we need? But go ahead.
So batteries, I think, for, say, maybe a little bit of load shifting so we can cover the afternoon peak. Batteries up to maybe 4 hours, I think, are going to make a lot of sense, but cost is coming down, and it's debatable how far they're going to come down. I do worry about, the unsustainable mining on lithium, and we're not getting recycling set up right yet. But so I don't do research in lithium ion batteries, and I don't do research in PV. Those things are happening. They're going to take us a long way. They're probably going to get us certainly 80% of, 75%, 80% of grid electricity. And then the question is, how much do we electrify? And if we electrify a lot, then we're piling on, a big problem. So our research is in other types of energy storage. I think, when you start looking at real weather patterns and stuff, there are times the wind doesn't blow and the sun doesn't shine, and it can be a week or 2 weeks on end, or, you have a volcano erupts in places, or, forest fires. Look what's happening in California. I don't think they're seeing a lot of sun because they're artificially blocking it out. We need other types of storage that isn't that can handle longer duration, like a week on end, and seasonal to level out loads between winter and summer, so we don't overbuild. This is part of the system optimization, is for the whole year. Right.
Yeah.
So
your pure physics hat on. Do you say that the sun doesn't shine? As opposed to the practical engineering hat of running the grid, like the sun is, that's maybe didn't get to that part of my book. The sun doesn't turn on and off, but it's just the earth spinning, and
right.
You don't expose it. So, you can have, someone can say one thing or another, and you're like, well, that's mostly true, or it's totally false. And then here we get, say, the narratives, right?
Well, if you talk about relativity, it's from the frame of reference where you're standing.
Yeah, and that takes longer to say, right? So that's, yeah. There's a question here on, well, and so you kind of started thinking about it or hinting at it at the end of your presentation, but this is kind of on the growth-based economic model. Right now, gross domestic product is effectively the metric that most people talk about or look at, and according to my research, for better or for worse, it does seem to be a good metric of physical material consumption, and was never meant to be, you know, a social welfare metric per se, but in some sense, that's how it's perceived, perhaps, to the person who doesn't think about it academically like we might. So what's going on there about either focusing on different metrics or, yeah, measuring this sort of quality of life thing, so that if you tell someone, you're like, yeah, I know you're not driving as much as you used to, or you're not consuming materials as much as you used to, maybe you're not even aware of it. Do people have to be convinced to think about different metrics, or to get away from growth-based culture? It could be growth of in debt as well, and growth of credit, which is a little bit more of the capitalistic system, you know, loaning money to do stuff and then forcing people to go to work so they can pay back their loan. That's part of something that grows that might be unsustainable. That's what I think about. But anyways, other thoughts about what y'all are looking at there on this paradigm?
Well, yeah. So, I mean, a lot of other people, and this is not really my expertise, but a lot of other people, of course, will try to look at these other metrics. And I think we really do need to get to a quality of life metric. I mean, you know, as a simple example is, you know, a society that's spending a lot on healthcare and not on preventative maintenance, you know, is increasing the GDP, but it's clearly not a good thing. You know, if we have a lot of people getting, you know, if we have a lot of air pollution and a lot of people getting sick and spending a lot of money on healthcare, it's going to increase the GDP, but it's not going to increase quality of life. So a lot of the things that we need to, you know, be really looking at is, you know, an improving quality of life, and measuring, you know, the quality of the degradation of our ecosystems and stuff. None of that is captured in the GDP. So it also, I think, you know, clearly puts in some of the perverse incentives, you know, to consume more, you know, as opposed to, you know, improve quality of life by what you're consuming.
Right. So some metrics, yeah, what the, you know, genuine progress indicator sort of get in the subtract the bads from GDP at least, and do some things about inequality. One thing, of course, I just point out in my book, let's just say for the US and quality of life, GDP in this metric sense has been going up, but in the last 2 years, this is what has been the, I guess, so disconcerting thing is that some demographics have been decreasing their lifespan in the US. So there's a one major metric of quality of life that is in fact going down, while the metric of GDP of the country is sort of by the numbers going up. So that's already a discontinuity that we could use to discuss with people. You're like, look, these two things are not the same, because look, they're going in the opposite direction now, and we can maybe make them switch their directions. Quality of life up, even if GDP goes down.
There's that, and there's also some people might be getting better off while others are getting worse off. And so this is also something that we see a lot also in science and technology. When we lose something very important when we only look at averages anyway, or only look at totals. We have to also look at distributions. And I think we have to say, with everything, a lot of things will get better if the people at the bottom of some of these distributions, and some of them are, you know, in the US, they're not just in faraway places. Mm-hmm. You know, there are, and that's why I prefer to use sort of an income measure anyway. I mean, it's still a loose measure, but I think it's closer than GDP in terms of, you know, what people can, is what they have that they can spend on their lifestyle.
Right. So this is difficult. This is probably a challenge maybe in general from an educational standpoint of the size of something, whatever the metric is, and the structure and the distribution of the components that make it up. I think that's important to point out. In my book, I mentioned this, a circle. It's like the economy of the US was like a circle in 1970, and now it's more like a triangle. So yeah, the triangle is bigger in area than the circle, but it's a triangle, and it's a different structure. And do we like that, or do we not like that? Is kind of a good question.
You can also have double peaks. You know, you might be looking at the average and nobody's there.
Yeah,
nobody's either below. I mean, yes, I think it's very important in almost anything when we're looking at the numbers. Couldn't, you know, go into all that, but looking at the distribution, the shape of those distributions, and how the shape is changing over time, not just the average.
Yeah. Now we got two things to optimize, and we have this conundrum that you already brought up, which is you can't optimize each one individually. It's got to be some combined effect. Here's another question here online. Good one. Your whole center, in some sense, is focused on, as you say, in some sense, the last 20% of getting low carbon. This is a question: what kind of government incentives should exist or could be implemented to think about carbon neutrality and some of these net carbon technologies, or direct air capture, for example, taking carbon out of the air. Do we have enough? Do we just have to press the policy button on that and get it done, even if it doesn't look economic from a GDP standpoint, because we just have to get it done, or what?
Well, I think first off, I think it's a little question. We have to get the right incentives, and that means a price in carbon one way or the other. One of the things we're starting to look at is in terms of the system optimization, what policies give us levers and push us in the right direction, and what don't. I mean, and you got to worry about what's politically palatable. Well, a lot of people like a tax for a lot of reasons. It seems very hard to get a tax passed for some reason, even though it's simpler and it can be revenue neutral or stuff. So some kind of cap and trade or various possibilities. We've got to put more attention into getting the right price signals in place and the right incentives to get it done. So a price on carbon immediately, but a price on carbon, the other problem with the tax is it doesn't guarantee you bring it down. Because if people can spend the money, they spend the money. And that's why I kind of like some combination where you do force that it has to start coming down
Right.
at the same time as you're putting some incentives to, to help the fledgling new technologies get a chance to make it into the market. And there's a lot of market barriers, and a lot of people, they'll knock renewables and talk about the policy incentives. There are very few policy incentives anymore. There's still huge incentives on fossil and tax breaks and all kinds of things, plus the way the ecosystem all developed around it. So the incumbent, whether whatever the incumbent is, they always have an advantage, and you've got to help the minority, the person, the one who's trying to get into the club.
Right. So you tacked on one of the other questions, which was asking about, I guess, subsidies in some sense across the board, but in particular incumbent or fossil fuel industry. So check on that. You touched that. Here's a good question, I think. A energy symposium in the past, I think 1 or 2 years ago, was a colleague, Susan Crumdyke, is at University of Canterbury in New Zealand, and she's come up with this idea of transition engineering. And she has this idea that engineers will, if you get us together, me being an engineer, just refuse to design, refuse to make the quote unquote wrong infrastructure or high carbon infrastructure, in the sense that if you don't make it and you don't make it wrong, you won't have the carbon emissions. She translates this to safety engineering as a thing that engineers said, like, I'm just not going to design an unsafe building, and even if your manager tells you to. So this leads into this question, do engineers and scientists have a role to play, or maybe a particular different role than economists or sort of policy analysts in making the energy transition equitable? Should we, does engineers have something to play in here that a policy sort of analyst or someone looking at regulations wouldn't normally think of, or is going to miss?
Wow, that's a tough question.
Maybe they're better at understanding, and physicists probably better at understanding distributions, and they have gone to Wall Street as quants because they can understand things besides a normal distribution and a power law or something. But
I think it's kind of impractical for an engineer. It's like for engineers to unionize enough to say, well, we're just going to boycott that. What the engineer can do and should do is come up with more sustainable options, try to develop the new technologies that are more sustainable, and then with the right incentives, the companies right now the companies, they want to do the right things. You know, I know we have this thinking, you know, that industry is just evil. Well, it's not. They're just people when all's said and done. And a lot of industries, you know, are really, you know, they're making the pledges. They're looking for the options. They used to say when I was at Ford, you know, if we didn't make a profit, then some people would say businesses exist to make a profit. What we used to say at Ford is we have to make a profit to exist. And we do exist to make the world a better place on whole. And if we're not, then we're not a great company.
I guess that's a good question. What if you made everyone less profitable at the same rate? If you thought this was needed for, you know, low carbon transition and capping consumption or something.
I don't think it's practical.
Limiting the profits even at a economy-wide level.
Limiting the profits? No, I mean,
that would go to the shareholders. I mean, this gets part of distribution, right? There's only about 10% of all people in the US that own like 80% of the stock, right? So it's not equally distributed there. So profits are going to shareholders. So is this part of the, how do we think of that?
I don't think we can, I think we need to put the right incentives and the right market mechanisms and then let competition do its thing. You know, we have antitrust laws and stuff. I know that, I mean, there are fallacies in our economy. I think it's kind of like democracy. Capitalism's not perfect, but right now, you know, it's the best we know. It's got a lot of the features right. I like to think in terms, you know, let's not throw the baby out with the bathwater kind of things. I think we tend to do that a lot. But, you know, look at what's working. Be sure to preserve that because it isn't all broken. There are things that we do need to fix, and let's, you know, get the best minds. Those, I'm not an economist, you know, but get the right minds together to say, okay, there's got to be solutions that can at least move it in the right direction. Right. We might have to do it in steps, but move it in the right direction.
Yeah.
Trend line's going right. Some of the things right now are obviously moving in the wrong direction. Those are the things we have to reverse.
So along the lines of, I guess, incentives, this you mentioned at the end of your slides, I think Amazon and Google as examples, you know, trying to go 100% renewable and actually thinking about the timing on an hour or 5 minute or, you know, 1 minute basis of, say, their at least electricity consumption. So they're feeling some incentive, which is not a tax or a carbon tax. It's something from, you'd say if they're customers, I mean, this whole deal and whether you're the customer of Amazon and Google or whether you're the client and giving them information. But aside from that, and then tracking your data, they're doing this, or they claim they're doing this. Do you think they're, you know, I don't know, you think it's a legitimate concern? I don't know if you've talked to any one of these companies, you don't have to talk about them particularly, but it seems to me that, yeah, if they're the most profitable companies and they're two of the most profitable, then yeah, they should probably, it's good for them to go ahead and try to solve this problem.
And to show leadership. So actually, I skipped by it very fast, but this is a lot of the reasons for my optimism, because even without the price on carbon, even without all the right incentives, a lot of things are moving in the right direction. I mean, there's been some policy, you know, low carbon fuel standard in California, for example, states putting into legislature, you know, into the legislative actions of 100% carbon neutral by, you know, Hawaii did it, I think one of the first, New Mexico did it where I live, quite a few other states. I did very briefly touch on it, and companies are making these pledges, utilities are making these pledges. No one's forcing them to. They do feel the incentive to do the right things and to show the leadership, because when there's a gap and the dearth of leadership elsewhere, somebody oftentimes just steps in, and that's what these companies are trying to do. I think a little bit of policy support would help them, but I think they're, you know, this was some of what gives me a lot of optimism, because they're just going and doing it.
Right. Good.
And seeking out options.
Right, right. Yeah, so you mentioned at the end, you need more options. Like another way to think is, do you actually need, we could have more options in total, but are some of the previous options need to go away? Would you ever think about removing an option? Let's just say, I don't know, coal-fired power plants.
No, okay, so that's,
And
yeah,
that's an
I
option.
touched on, that's an option. So fossil has to go away. The question isn't, does fossil have to go away? At least fossil carbon emissions have to go away. The question is on exactly what time scale that it has to, and and what we can do in the transition. We have to get to carbon neutral. Carbon neutral and fossil free are not one and the same statement. So, but coal, the interesting thing about coal, I took the slide out in the interest of time. Coal is going away all on its own. In the US, pretty much by the 2035 or so, you're going to see practically no coal plants left. We've already reduced our coal plants roughly in half, and a lot more scheduled to phase out. Coal is simply going away, and it's not going away because of environmental concerns. When all of a sudden, it's just simply not the most economically attractive option anymore. It's just not economically viable. So mostly because of natural gas, and also because
You think that's mostly a US or Western world phenomena versus?
well, no, a lot of other countries are starting to phase it out as well.
Right, as opposed to building more. I mean, some are still planning on building more. But.
Right. So yes.
But they have the other options are taking up a larger proportion, certainly, than they would have without the wind and solar option, at least.
I think the bigger question is the transition, because natural gas is cleaner than coal, so it's a step in the right direction, depending on how you manage the methane emissions, and that could be a real issue. What is the future of natural gas is a big open question. And so options for what is the transition. I'm not actually in favor of obsoleting all of our all of our infrastructure and starting clean slate. People talk about how much that, would cost us. So in part of optimizing of the system is also optimizing to utilize the resources that already exist.
Right, right. Yeah. So thinking of the economy, if you think as a superorganism, most organisms don't, cut off a part of their body that they've already generated to go forward. That's the difficulties here. We're talking about whether we should get rid of part of the way the economy operates or change it in a significant way. So maybe we'll end on something that might be in your wheelhouse and you just started touching on, which is sort of natural gas. You got carbon capture, thinking for natural gas, from a physics or chemistry standpoint, you have the span of, I guess, at least for major fossil fuels, the relatively high concentration of CO2 and flue gas of a coal-fired power plant, then down to a gas plant, then to the air, and just direct air capture is the lowest concentration. So where do you see the challenge in CO2 capture on this broad span of things? I know there's people working on it there, and the Klaus Lackner's lab focuses on this.
So I'm a big fan of direct air capture, and it's a whole separate talk, but we think the problem gets much harder at lower concentrations, and it does get harder, but it gets logarithmically harder, not linearly harder. And there is, there's been a lot of controversy in the literature. There's something called Sherbeck's rule of that the cost to separate goes inversely with the concentration, so that it goes up. Well, that's primarily because, it's really come out of mining. And so as we get more and more, but you have to handle all that rock, to smash it. And that's where all the cost is. When you're doing direct air capture, that volume you have to handle the air. This is part of also go by the numbers, run the numbers. It's a lot of air, but it's not very costly to move when all is said and done. And so that isn't the dominant cost. So you move into, a very different cost equation. And then when we're optimizing at the system, because you can, put it right where you're going to use it or right where you're going to bury it, you don't have the transportation. Here, eliminating transportation helps you a lot.
Democratic, just like solar, maybe.
Yeah, it's very democratic. And so on a systems view, it doesn't necessarily have to automatically be more expensive. That's number one. And I think the fundamentals say we can make this reasonably cost effective. The other thing I like to look at is, when you say it's just a cost, but coming back to profits and the economy, if you remove 1,300 tons from the atmosphere over the rest of this century, and you're making $5 a ton profit, that's a big industry. So part of, the economy, if there's a need, we can build economy around it. People can make money and people can improve their lifestyle. They have economic opportunity. So that's kind of how I look at it. I see no point really in just capturing, from the concentrated sources. Then from the concentrated sources, I just touched on this. One of the things we've been looking at is how to pre-concentrate in a sense. So if we redesign the system a little bit in those gas-fired plants, we can get what we call capture-ready CO2 and do the separation elsewhere in the system. This is, some of the research that we're doing. We just got a paper accepted on it. And then the capture right at the back end of the natural gas becomes really very little cost. So that's, to me, where I'd like to see some of the natural gas and combined heat and power be able to go, an option.
We're kind of at time. You've thrown a lot
Sorry.
of interesting things there. So I think the Sherwood rule, I think I'll have to have you forward me something on that and how it's traditionally related to, I guess, moving mass around or solids around, perhaps what you're saying. But if you're moving around a fluid, then air, then maybe the cost is different. So I'd like to understand that. You've kind of mentioned other natural gas. Of course, there's the alum cycle design out there. I don't know if that's something that y'all could, I don't know. I can't remember if it's proprietary or patented for the design of the company, which is blanking.
We've looked at it.
I'm blanking on the company's name now, but
yeah, I'm blanking on it too.
Yeah. I don't know if you have anything to say on that. We could end on that. So you're pretty optimistic for the direct air capture. If you can make them profitable. So I guess my challenge from a economic quasi-economist now is we are in charge of defining profits, right? The profits are based upon what we put into the cost of goods, including carbon. And some companies have lower profits under a changing set of rules. Some companies that have positive versus negative profits under a changing set of rules. So it is a definition of us as people in the economy.
What you put into the cost.
So I've enjoyed this conversation. I learned a lot, and thank you for everyone in your questions. Sorry if I didn't get to every single one, but I sort of got to all of them. So yeah, Net Power, there's the name of the company that we can't.
Net Power, yes. I knew it was Net something. Thank you. Yes.
So thank you very much for that comment. And online, and Ellen Stechel from Arizona State, thank you very much. I enjoyed the conversation, and thank you everyone for joining. So
thank you so much for inviting me. Thanks to the unseen audience. I really wish I could see an audience when having these conversations.
Right. It's a little weird, but all right.
It is.
Thank you.
Thank you.